Everyone, today we're announcing our next generation, the RTX Blackwell family. Here it is.
Hey everyone, today we're breaking down NVIDIA's huge CES 2025 announcements. Jensen Huang just dropped some massive news that's going to shape the future of gaming, AI, and robotics. Let's dive in. First up, the RTX 50 series is here, and it's an absolute beast. The flagship RTX 5090 delivers twice the performance of the 4090, while the RTX 5070 gives you 4090 level performance for just $549. The real magic here is in the neural rendering. These cards only compute about 2 million pixels and use AI to generate the other 31 million. It's mind-blowing efficiency that lets them even fit 5090 level performance into thin gaming laptops. All right, what I'm sharing now are the specs for the 5090, the 5080, the 5070 Ti, and the regular RTX 5070. And these were all the ones that were announced with the new NVIDIA Blackwell architecture. And you can see they all use DLSS 4, which is the latest kind of machine learning upscaling. So if you're at lower resolutions, it'll make it appear like it's a higher resolution without too much compute power. You can see the AI tops really going overboard for the 5090. I mean, in a good way, but 3,000 compared to just under 1,000 for the 5070. The tensor cores that do a lot of the AI processing for the neural networks, these are all the latest 5th gen. Ray tracing cores, 4th gen. Ray tracing is for reflections off of water and things, or light scattering. It just gives things a much more realistic and textured appearance. The NVIDIA encoder is, I don't know too much about this, but this is a 9th generation, and the decoder 6th generation. The memory configuration is the big one. This is kind of insane. There's a 32 gigs of memory. So the memory is offloaded from the PC and really the chip to the GPU, which is the card that goes in your computer. And if you're gaming, you know exactly what I'm talking about. But the higher level of memory, the more that the processor can handle sort of in real time, and it just makes it way faster. So 32 gigs compared to 12. So you're looking at almost 3 times the amount of memory that's in the 5090 card. And this is reflected in the price as well. And then memory bandwidth. So how many gigs per second can this thing process? So you see 1700, which is pretty amazing. This next chart, this is the comparison of specs you can see between the 4090, which is the current card, and the 5090, the one coming up. So multi-processors, 128 to 192. The CUDA processing cores, 16,000 to 24,000. The ray tracing cores, again, this is for the lighting and the effects, and particularly when you can see it, definitely when you get into the 4K territory and above. 128 to 192. Tensor cores, these are, again, what processes the neural networks and does the AI heavy lifting. So 512 to 7068. So really boosting the performance up for this thing for AI. The boost clock, 252 to 2.9. This is just gives it a turbocharge. The layer 2 cache for the caching is 72 to 128, and then the memory bandwidth is 1,000 to 1,500. So all of the caching, the memory bandwidth, the cache sort of preloads things or keeps them in memory as well, and just makes the whole thing that much faster. But the numbers are extremely impressive. I mean, I'm looking forward to selling a liver or something to get a kidney to get one of these, my hands on one of these chips, because particularly for 4K gaming, if you're doing it in high resolution with ray tracing, would be amazing. I mean, I think it would look photorealistic. Now let's talk about the Blackwell performance powering all this. We're looking at 92 billion transistors, 4 petaflops of AI performance, and memory bandwidth that NVIDIA says equals the entire internet's current traffic. Yes, you heard that right. They're manufacturing these in 45 factories worldwide, which shows just how massive the demand is. And here's where things get really interesting. NVIDIA unveiled Cosmos, their new world foundation model, trained on 20 million hours of video. Think of it like ChatGPT, but for understanding the physical world, physics, dynamics, and how objects interact. They're making it open source, which could revolutionize robotics and autonomous vehicles. Speaking of autonomous vehicles, NVIDIA is already doing $4 billion in this space and growing fast. They announced their new Thor processor with 20 times the processing power of their previous gen, and it's the first AI computer to get the highest automotive safety certification. The big news, they're partnering with Toyota, adding to their work with Tesla, Waymo, and Mercedes. NVIDIA sees three key areas in robotics: AI agents for office work, self-driving cars, and humanoid robots. Their new Isaac Group platform lets you train robots in VR using an Apple Vision Pro, turning a few human demonstrations into massive training data sets. It's pretty sci-fi stuff becoming reality. Finally, they revealed Project Digits. Think of it as a personal AI supercomputer. It's aimed at developers, designers, and artists running NVIDIA's full AI stack. It's coming around May 2025, and while we don't have pricing yet, it could be a game changer for individual AI development. And it's about the size of a Mac Mini. The takeaway here is that NVIDIA is not just pushing graphics anymore. They're building the foundation for AI, robotics, and autonomous vehicles. It's a massive vision, and they're executing on every front. That's it for today's breakdown. Drop a comment with anything that might have excited you. And don't forget to like and subscribe for more tech coverage. And as always, thanks for watching. One comment that I decided to add at the end is about the automation of everything and the effect that that's going to have on workers. One of the issues and my concerns is for the people that are working in Amazon or warehouse or truck drivers or other jobs that are still some of the few remaining blue-collar jobs that haven't been outsourced to other countries and aren't manufacturing, that those things, I mean, everything in Amazon will be automated because workers now don't even have time to go to the bathroom. They just are constantly on the go. And obviously the machines, the robots can just go 24/7. They don't need breaks. They don't unionize, nothing like that. So I think it's going to have these things are going to have profound social impact. So while I'm enamored of the technology, I'm a little bit wary of the effect it's going to have on people. And so that's it for today's session and essay. And thanks for hanging out and joining me. And I'll have more comments later.